Coordinates. Recall that when we start with an ordered basis for Rn, what does it mean? Well, an ordered basis has a first element and an nth element, which cannot be switched. Then we know that each vector in Rn can be spanned, can be expressed as multiples of these vectors v1 to vn. And actually the constants or the scalars that we use are uniquely determined. So for each x in Rn there are unique constants, c1, c2, so Cn such that x equals the sum of C1 V1 plus C2 V2, etc. C1 Vn. So conclusion, if we use these constants with respect to the new basis as new coordinates of x, then actually the vector of coordinates of x with respect to the new basis, so we write xb is the coordinates with respect to the new basis is well defined. So they are unique Cn, C1 to Cn. For example, take an ordered basis with the following two vectors v1, v2, 1 minus 1, 3, 2 for R2. And the vector x is 1, 2. So we determine the coordinates of x with respect to b. Well, this amounts to solving which linear combination of 1 minus 1, 3, 2 creates 1, 2. So we solve the linear system 1, 3 minus 1, 2, and the augmented matrix with x as the vector of known terms 1, 2. So if we do this, then we see that we end up with the reduced row echelon form and the following reduced row echelon form, from which we read that actually the first coordinate should be minus 4 over 5 and the second one 3 over 5, so that the coordinates with respect to this basis of x equals minus 4 over 5, 3 over 5. Well, we may check if this is true. So check that x is indeed this special combination of the vectors v1, v2 by just multiplying v1, v2 times the new coordinates x, b. So we get minus 4 over 5 times v1 plus 3 over 5 v2, which equals minus 4 over 5 times the vector 1 minus 1 plus 3 over 5, the vector 3 over 3, 2, which is a vector minus 4 over 5 plus 9 over 5, and the second coordinate 4 over 5 plus 6 over 5. So it's clear that this is no more than a vector 1, 2. So this seems all to be okay.